Good morning, everyone. This is Matt Sexton with the Florida Department of Transportation's CAD office. Welcome to another webinar from our CAD Hot Topics series. Today, the topic is Custom Drainage Structures Pond Control. The presentation is done by James Worley. One note, if you're having problems with the audio, the easiest way to resolve those issues is to log off and log back in. We are doing a portion of this presentation as pre-recorded, so the audio will only be available to people that are connected to the computer audio and not dialed in. It looks like almost everyone is connected to the computer audio, so that shouldn't be a problem. There is a question and answer portion of the dialogue. If you pull that question and answer window out, you can enter questions that you have, and we will be trying to answer those questions in real time. If we do not manage to answer your question in real time, we will compile a Q&A document that will be posted with a recording of the webinar. The recording will be posted at the same location that you registered for this webinar on our website. So without further ado, I'm going to turn things over to James.
Welcome, everyone. Welcome, everyone. My name is James Worley, and today I will be presenting Custom Drainage Structures Pond Control. Let's get started. First thing you need to understand that there are requirements that you have to have in every one of your custom drainage structures that you'll be required to make. And basically there's a combination of 2D and 3D cells that are used to assemble all your ORD drainage node elements. There are currently two kinds of drainage node elements used by FDOT. A standard, which is basically all of your inlets, manholes, and etc. And then specialty nodes, which are the MESs, FESs, end walls, basically anything that is a single element that will not require two of the 3D cells to complete. Standard nodes, the ones like inlets and manholes, use 3 cells, 2D plan, 3D top, and 3D bottom. A specialty node only uses 2 cells, which are the 2D plan and 3D bottom. The use of multiple multi-dimensional cells in ORD drainage structure nodes requires some method for you to align those cells consistently when you're placing them. This is achieved through the use of points and lines on specific line styles. Basically, an alignment point or an alignment line, they will be on your line style 3. These actually are used to align the cells horizontally and in a rotation. Location points are the next, and they will always be in the 2D cell only and will be line style 4. This actually is where you place the cell. This point will be the what used to be called the placement point in our geopack drainage cells. Elevation point for a top will be line style 5, and it will be the position for the top elevation. In other words, at a manhole cover or wherever the elevation location point is for the cell via the design standards. You'll also have an elevation point for the bottom, This will be in the second of the two 3D cells in a standard node and will be at the top of the slab for the bottom box. This will give you the position of the bottom elevation at this point, that is the invert of the structure. That will be where the invert of your pipes coming in and going out of your structure will align with. The last thing will be a connection region. Those will be line style 6. Those will be either a shape or a cone, better known as a cylinder, and those will be the positions where the conduits can actually make a connection to your drainage element. When you place a drainage structure, a couple of things happen. The location point of the 2D cell is positioned at the coordinate that you specify, which could be XY, station offset, etc., or just a data point. This is done in the 2D view and is the beginning for you placing this cell. The alignment point in the 2D plan cell provides a horizontal position for the alignment point in the top 3D cell, and the alignment point in the top 3D cell in turn provides a horizontal location for the alignment point in the bottom 3D cell. Next, the top 3D cell alignment line rotation is matched to the rotation of the alignment line in the 2D plan cell, and the alignment line of the 3D bottom is aligned to match that of the alignment line of the top 3D cell. This means that depending on where you place the cell and what rotation you use, it will make sure that the 2D cell and the 3D cells agree with one another. It then uses the top 3D cell elevation point to locate the top 3D cell vertically in your file. You can use a specified value or actually have it snap to a surface element. The bottom 3D cell elevation point is used to locate the bottom 3D cell vertically. This location will be determined by either the invert elevation of a pipe or the default minimum height of the drainage structure feature definition. Any gap between the bottom of the top 3D cell and the top of the bottom 3D cell is made up by an extrusion of the top surface of your bottom 3D cell. So what this means is basically if you have a 4x4 box and it's located 20 feet below your top cell, what will happen is the software will automatically extrude up the top surface of that bottom cell so that it aligns with the bottom surface of the top cell that has been located by your elevation of your surface elements. When a pipe is connected to a standard node, the invert elevation of the pipe is used to determine the elevation of the bottom of the 3D cell based on the location of the elevation point of the bottom 3D cell. So when you place pipes or add pipes, the lowest elevation of all pipes that are connected to a standard node is used to determine the elevation of the bottom 3D cell, remembering that the standard node has a specified minimum height. So basically what that's saying is that you can change the elevation of the bottom slab of your 3D cell by lowering the invert of the pipes coming into that particular structure. The inverse is not always true. You may be restricted from raising the elevation by using the bottom cell point or the invert of the structure. So changing that value may or may not allow you to raise your pipe invert elevations. For specialty nodes, the location point of the 2D plan cell is positioned at the coordinate you specify, which could be XY, station offset, etc. The alignment point of the 2D cell provides horizontal position for the alignment point in the bottom 3D cell. You notice it doesn't say anything about a top 3D cell, because all specialty cells, all end treatments like end walls, FES, MES, or other, are all a single bottom 3D cell. There is no top, and that allows the software to understand, along with the addition of an extra point, that this is a specialty node. The bottom 3D cell alignment line rotation is matched to the rotation of the alignment line of the 2D plan cell. The uppermost elevation point, which is the added point that these have that are different from a standard bottom cell, is used to establish the vertical location of the bottom 3D cell, usually on or near the top of the cell. The lower elevation point is used to establish the invert elevation for the structure. So basically what this is saying is all of your specialty nodes will have, unlike all other bottom 3D cells, two elevation points, a top and a bottom. Why custom drainage features are needed. The reason a new drainage feature definition is needed for any variation of structure top and bottom combination or modified component is that the feature definition has static components. The feature definition cells on a specific feature symbology that in turn call specific element templates to make the ORD drainage structure assembly. All of these values set to specific things like cells, templates, and such. So a change to any of those values requires a separate set of these definitions and templates. As you can see in the illustration, your element templates call your general settings, which sets level information, and your cell settings, which actually call the cell that will be used for that particular element template. The next portion is to actually go within your standards and look at your feature symbologies. In your feature symbologies, each drainage structure will have a point feature symbology and a solid feature symbology, and those will be located in a directory tree structure as illustrated in the diagram. Finally, once that is set, you will be able to create your feature definition. This will be your node definition for your drainage structure that you've created. So, where do you actually get started with this? Well, the best way to get started and the most direct workflow, if there is a similar structure in the delivered structure list, place it where you want the new structure. If not, Find a delivered structure that is functionally similar and place it instead. So if you have something that's going to be a completely custom structure, meaning that you actually create the top cell and other components from scratch, which is possible, you need to place a structure that would have a similar functionality. So if you had a grate inlet that you were creating from scratch of some unknown size, then you would want to place a type of grate inlet, and that will become evident. The reasons why you need to do that in just a few minutes when we start doing the construction of our pond control structure. Okay, so if you need to physically change the shape of any of the cells, you're going to need to open the appropriate cell library, meaning DR plan for proposed 2D, DR plan underbar EX for existing 2D, or the drain 3D for both existing and proposed 3D cells. You'll need to open those and make modifications within the particular cell library that is needed for the custom structure you are designing. When all the cells you need to make the new structure are in the cell libraries, it is time to create the element templates, feature symbologies, and feature definitions in your drainage work file. So, I guess it's now time to move to making the structures. For today's scenario, the design calls for a proposed pond control structure based on a type C DBI, as you see in the picture. So here we have a design file with a type C DBI connected to an MES. This would be similar to what you might use for a pond control structure within your own project. First thing we need to do, since the type C is already placed, is to figure out where this is stored in our file. So we'll open up Explorer and we will go to Open Road Standards, Open Standards, then the DGN file you're currently working in, and you'll need to look at the feature definition real quick. Drainage and utilities, node, stormwater node, drainage structures. In this current file, there is only a grate for the type C and an outlet for the MES. We'll open the grate branch, and you'll find the feature definition for the DBIC no pavement. When I click on this and then bring open my properties window, we can see that the DBIC no pavement has a feature definition of DBIC no pavement and all the specifics of this DBI. we'll see that the symbology for this is calling a point feature symbology of DBIC no pavement, and that the solid feature symbology is calling for a DBIC no pavement. These are the feature symbologies that are used to create this feature definition. So investigating further, we'll close the feature definition, open the feature symbology, take a look at point and at solid, and look under the node branch, then stormwater node, and then grate. Now under here you also see the DBIC no pavement feature symbology for a point. Clicking on it brings up the properties, which if you inspect, you see that the plan, profile, and 3D properties point to different, let's see if we can bring this out a little further so it's a little more, okay, there, a little wider so that we can see the entire path. Alright, here you see that the plan, which would be your 2D, has an element template calling out for drainage structure grate plan DBIC no pavement. Your profile is going to a generic grate inlet profile template, and your 3D template is pointing to a DBIC no pavement 3D top. Alright, make that a little smaller so we can see things on the screen. Alright, and that is your point symbology for this current structure. Now going to the solid symbology, opening the tree at the node, and then the stormwater node, and then grate, we have a DBIC no pavement node definition under the solid area. When we select that, we see that this particular definition only has a place for 3D properties. Now these 3D properties, just like the ones in the point properties, point to a top template, and in this case a bottom template. So the top template also points to the 3D top DBIC no pavement. The bottom template points to the bottom for this structure, which is a P bottom type C DBI. That is a special bottom structure designed specifically to fit type C DBIs. The fact that we're going to be making a pond control structure out of this means that the top template will change, but the bottom template will stay the same when we make our copy. Now to actually look at these templates. To get to the templates, a very simple way to do that is to go to Home, where you see this, go to the bottom and Manage. This will bring up your element templates. Now the particular ones we're interested in are, starting with the bottom, the drainage bottoms P bottom DBI, type C DBI, excuse me. So what we would need to do is go into the current file, drainage bottoms, and there is the element template for the P-bottom type C DBI. And of course it calls for your active cell for this element template is a P-bottom type C DBI. If we look at the top is under Great 3D Top DBI-C No Pavement. So we look under Drainage Structures, Great 3D Top DBI-C No Pavement. And when we look at that, we see that it points to an active cell of type C DBI No Pavement. Keeping these things in mind, we're going to need to go into our 3D cell library and make changes to that particular cell after we make a copy. So let's start another session of Open Roads. And now we're going to want to go into the Train 3D cell library. Once in your cell library, open your Models dialog and scroll through until you find what you're looking for, which is a Type C DBI No Pavement. As you can see, there's only a few cells to have to sift through. And now we have single slot, double slot, modified, Type C DBI No Pavement. Hey, right there it is. Okay, so we're going to want to go into that model. Once you have that, the only thing left to do is to make a copy of this. So go to the Copy a Model. You see Type C DBI No Pavement Copy. Well, let's modify that. It's a very good idea to use the original name of the cell with a modifier on the end so that when you go back to change cells in your feature definitions that you copy, you'll be able to get to the cells a lot easier because they'll still be in alphabetical order and it will be near the original cell. So let's just call this pond control. And for that, we say OK. All right, now we see that we have the cell type C DBI, no pavement, pond control. Once we have this cell, now we can actually go within this model and make the changes to the 3D model that we are going to need for our structure to work. All right, now one thing that I have to stress here more than anything else, this is a 3D top cell. So this line and this point have to be at 0, 0 with their starting point. So you have to see all zeros here when you're looking at the line, which is for alignment, or the point, which is for location. So both of those have to have the originating point at 0, 0, 0. That is excruciatingly important because the bottom cell and the 2D cell both have alignment points that will coordinate with that to align these vertically and center them on that point for all three cells. So that in mind, we know this structure has to be taller than a standard DBI. The easiest way for this to happen is for us to use a fence command and set a fence so that it is above the top and through the area just below where the grate structure ends, as so. We then come back to our fence tools and we manipulate fence contents and use the stretch command there. Now in this case, this particular structure would need to be, let's say, 5 foot tall, just to be able to appropriately hold the weirs and have the orifice located at the position it needs to be. These are things that you're going to have to determine before you get to this point so that you'll know how far to stretch your cell. But I'm going to say 5 foot just so that we have plenty of room to work on placing the orifice and the weirs. So, using the stretch command, go to the corner, click, pull up, hit the enter key to lock your axis. Now no matter where I move the cursor, it's not going anywhere. And then continue up and hit 5 on your number pad to make that the distance in the Y direction you're traveling. Click in the open, and now you have a much taller cell. This structure is now much taller than it was before, and you can see that in all of the views, except for the top view, of course. Okay, now the next modification we're going to make is a little bit more complicated. This modification is the next modification, I should say, that we're going to make is putting the weirs in the front side of this structure. So to do this, we're going to need to place a rectangle in order to use to cut our weir out of the side of this solid concrete structure. But we also do not want to cut both the front and the back of this structure. We want to only cut the front. So to determine front, we use this line actually it is pointing towards what should be considered the back of this structure. So we'll want to cut this front face and not this back. So to achieve this, we're going to need to place a block. Now, to do this, we go to our drawing tools, place polygon to place a rectangular block, and then come to the front view. And at this point, you need to know how deep your weir is going to be from the top surface of your structure. Now, in this case, we're going to say the weir is 2 foot wide by 1 foot deep. So what we're going to do is, in space somewhere, click and pull down, hit the enter key, press 1.5 on your keypad, then go down and unlock the X and go over and type 2 for 2 feet. Now click to place. Now you can see that you have an element in your file that you can use to slice a hole. Problem is, it's not located where we need it. So what we're going to do is use the element select tool to select it and then click on the move tool. Now using your automatic snap, snap to the center of the bottom. Now allow it to snap to the center of the top of the structure. Press the O key on your keyboard to bring up the compass origin. Then go directly down, hit the enter key and then the number 1 and click and open. You now have moved that to the front surface of the particular wall we're wanting to cut. The problem is, if we use the cut tool where it's at, it will only allow us to cut everything that is either forward from this shape or behind this shape, or in both directions. And that is not what we want to do. So what we'll do is go to the right view, click on the shape, click on move, let it snap to the top of the shape, click to accept, and then drag straight towards the back and hit the Enter key again. This now locks your axis. So now we can go just inside of the structure so that we can use either the front or the back direction from this to just cut out that one wall. Now you can see in the 3D where that moved to. So the next part is pretty much simple. We're going to use a 3D manipulation tool. All right. Finding it is often fun. Easier way to find this particular tool is just go to the drawing or modeling workspace and go to, well, let's go to modeling. Modeling is much easier to find it. And we'll go to the solids tab, and down here somewhere is cut. Now we're going to use cut, and it's going to ask you a silly question. Do you want to make this kilometers? No. And don't ask me again for this model. You don't want to adjust your units, believe me. Okay, now having the cut active, if you'll notice down here it says cut solid with curve. Select the solid or surface to cut. So we're going to select this solid. Now you see a cut direction of forward, cut mode of through, and the profile. The profile hide, show, copy, and hide. That is referring to the thing that we're going to use to cut with, that shape that we made. Orthogonal means it's only going to be able to go in the X direction, the Y direction, or the Z direction. It will not allow you to do slants. If you need a slant for some reason, you would cut that off. But for now, we're going to try it in the forward direction. At this time, it's asking for us to select the cutting profile, which is this shape. Now when you do that, you're going to see in this view there's an arrow pointing. Forward would indicate that direction, which is actually, if you notice where the line is pointing, is the back of the structure. So we do not want forward. We want back. When you change that to back, now it points in the proper direction. And all we have to do to see what it's going to do is click. And there it is. We have just created our weir. Now the next thing you're going to need to do is basically the same operation, but with a circle. So let's see where as I say, the easiest is sometimes just to change the area you're looking in here and use a circle. We're going to place this by center. We're going to make it a hole. We're going to have no fill, and we're going to do a specific diameter. For this particular one, we're going to use a 6-inch diameter. So that would be 0.5 feet. Enter. And now we're going to place it again. We're going to activate our front view, and we're going to place it in the front view somewhere around where we need it, which is about here. So now you see it appear over here in the 3D. What we need to do is by design, and you'll know where that orifice needs to be, the bottom edge of that needs to be 4 foot down from our top of our structure. So what we'll do is go to Move, snap to the bottom edge, and again we're going to zoom in and allow it to automatically come up with this little X. We're going to hit our O key on the keyboard to bring in our origin, and from there down we need to be 4 feet down, and I'll click. And at this point you can see over here that that orifice cutting element is not completely inside the structure. So what we'll do is go select Element Selector, grab this, and use the Move command to then snap to, move to the interior, hit Enter to lock the direction, and then just go in about the same amount we did for the weir cutting element. Now, sorry about that. Too many clicks. Remember to escape out of your command. I did not and had to undo a little bit. Okay, now to be able to cut that, we're going to need that cut tool again, which is much easier to get to if we go to Modeling and then Cut Solid. Again, it's prompting us for the solid to be cut, this, and it needs the element that we're going to be using to cut with. Since we figured out what direction it needs to go and already have it set to back, it's already pointed in the right direction. So all we have to do is, oh, no, it's not. Look at that. Wow. Even though we used the same placement method, the front and back is now backwards. So I need to go forward instead. Now we're pointed in the right direction. Remember, this line is pointed to the back, and in this scenario, all of the cuts are being done on the front surface of our structure. So now the only thing to do is click, and you have your orifice. If your particular structure required any other parts, you would have to physically model them here in this file. Alright, so now we have our structure that we want. In this particular scenario, everything is done. All we need to do now is take and make an element template of this cell, and then utilize that element template in order to create our feature symbology and feature definition for our new structure. Then we go into the file and swap it out. So with that done, we can close our cell modifying session and come into our element template modification here that we just were in before we went out to the cell library. We're going to do a copy. Click on that, right click, paste. It just made a copy of that original DBIC no pavement. So now I'll come here, and as I did before, I will give it a consistent name. Alright, now we have a DBIC no pavement pond control element template. The next thing we'll need to do is to actually swap the cell reference to the proper cell. When you click on this drop down, wait, because if you click it multiple times, it'll just take longer. Once the drop down comes up, scroll down and see if you find the newly created cell. And as you notice here, we don't. So always check to make sure it's not at the very bottom, which it's not. And if this is the case, that means it hasn't read that information. Let's close this and then reopen the tool just to see if that will get it to recognize that new cell. Now what we have to do is actually utilize the cell we just created in the new copy that we made. So let's try seeing if it's out there. And there it is. Once we make that change, we can now utilize this in our feature symbologies to create the next step. Now what we'll do is make a copy of our solid feature symbology by doing a right click and copy. It will increment the name by 1, and staying consistent, we will actually come in here and use pawn control as a suffix so that we'll be able to locate it more easily. Copy that name and then click. We've now changed the name, and now we can change the cell. Once you click, wait. And there it is, pawn control. Even though we didn't make a 2D modification, we still want to make a copy of the point feature symbology so that we can use it. So copy, come to the end, remove the 1, and then paste the new name. The only thing here is we will change the 3D element template. And that goes to the DBIC no pavement pawn control. Having these two created, we can now collapse our feature symbology and go to the feature definition. On the feature definition, under the drainage and utilities tree, under the node branch, and then the stormwater node branch, drainage structures, great. Yes, it does get a little deep sometimes. We're going to choose the DBIC no pavement that's currently in the file, and that will give us our properties. At this point, we're going to right click, copy, and now we have a copy. We can right click, rename, click at the end, delete the 1, paste the suffix, and click. And we are now working within the new pawn control structure definition. Now, the name has changed. The description needs a little change. And the feature definition has changed as well. Come down to point feature symbology. Wait for it. And there it is. Let's see. There's what we're looking for. Now we'll go to our solid feature symbology. Click it. Scroll down. There it is. If we had not used the naming convention I spoke of earlier, and we had changed this first part, you would have to dig through all of those entries in order to find your new symbology. With that done, we can allow this to close. Come out of this. Back to here. And allow this to close. At this point, we're ready for the fun. But just so we can see it a little better, I'm going to right click into open and go to the View Plan 3D. Now you can actually see that structure. We're going to click on the structure in the 2D, bring out the properties, look for our feature definition, replace it with pond control, and wait for the magic. And there it is. Oh no, look, it's oriented incorrectly. So what we then do is simply go to the 2D using the rotation handles, click on them, and rotate the structure. Now we can go to our 3D and you can see our new pond control structure. This is a very labor intense and particular process, but it is at the current time the only way to get our structures to be modified to the point that you can create things that are not delivered. Unfortunately, the current way things are, the delivered structures are all we have. So you can modify any of the delivered structures by modifying the cells that make them up, and then creating your element templates, your feature symbologies, and your feature definitions to then be used in your files. I would like to thank you all for attending today, the Custom Structures Pond Control webinar. My name is James Worley. I hope you have a wonderful day.
All right, thank you, James. That was an excellent presentation. Are there any questions in the Q&A dialogue that we want to address in the webinar, or we just want to go ahead and include those in the Q&A document?
I think we'll probably need to put them in the Q&A. They have been addressed, all except for the last one. and we will get back with you on, well, they've all been they've all been answered in the Q&A dialogue. We will document that and get them posted along with the video.
All right, that sounds like an excellent plan. I do want to once again thank everyone for spending your morning with us, learning about the custom drainage structures. We will have another webinar coming up soon. So thanks again. Have a fantastic day.